In this example, we wanted to give you an opportunity to see how we might go about measuring current with something related to our scales. In this example, I have a 480 indicator that has a 4 to 20 milliamp analog output card installed in the back. So typically we would use this in a situation where we want to send that 4 to 20 milliamp current back to a PLC, which is also properly scaled to match the range of the indicator. And so we want to verify that the scale is outputting the proper amount of current. In a 4 to 20 milliamp situation, we would see 4 milliamps at 0, and we would see 20 milliamps at full scale. In this case, I have a 10,000 pound scale set up here. You'll notice I have 388 pounds on the display. If our range is 0 to 10,000 for pounds, but our milliamp output is from 4 to 20, I would expect to take a measurement much closer to 4 than I would 20 in this particular case. Now, to measure current with our meter, we're going to have to make some adjustments. Up until now, we've left our leads in the same place, with our black connected to the common and our red lead connected to the portion that corresponds with voltage and resistance. Current has a separate reading, and current is typically going to be fused. So you definitely want to be mindful of what to expect so that you can place your lead in the proper position. On my meter here, this connection here will read up to 800 milliamps, whereas my upper connection will go to 10 amps. That's significantly more. And since I'm only expecting somewhere between 4 and 20 milliamps, my connection that goes up to 800 milliamps is going to be sufficient. So I'm going to make sure to place my lead here. So I'm going to go ahead and take my red lead, and I'm going to place it in that position. And then when I select my spot on the meter with the dial, I'm going to look for milliamps. This is our unit of measurement for current. The ampere is denoted by the capital A, and M for milli is 1,000th of an amp. And you'll notice here I have both the straight line with the dash line and the wavy line are the same setting on the dial in my particular case. Pay close attention to your own meter because it may very well be different. Ultimately, I'm looking at DC current, so I'm going to make sure that I have that properly set. If you do have a separate milliamp with the wavy line and a wavy end with the straight line, you want to go with the straight line option in this particular case. So I'm going to go ahead and I'm going to change my dial over to my milliamp setting. So now that I've got my dial set to DC current for milliamps, I'm going to go ahead and take a measurement. Now remember, this is very close to 0, so I'm going to expect something very close to 4 milliamps when I take the measurement. So I'll go ahead and place this down here so I can get to the back. Now in my analog output option card here, I have a plus and minus I as well as a plus and minus V. So V is for voltage. The I is where we're going to place the leads for the measurement of current. You might expect there to be an A there referring to amps. The I represents intensity, for the intensity of current. We'll go ahead and place our red lead on the positive and our black lead on the negative. And we see over on the voltmeter it says 4.6364 milliamps. Remember, we had a very low number of weight on the display, so we were expecting a value that was much closer to 4. If I go ahead and put a little extra weight using the simulator here and take a new measurement, I should see that that value has gone up. And it has. It's up to 8.67. That corresponds with 2,901 pounds on the display.